Welcome, Hornets, as I get myself set up here. Whee! Don't look too closely, but here I am. And welcome. Today we're going to be taking a look at the worksheet, which I have online here. This is the disk method number 3. We're going to be looking at the front side, evens only. And then I'm going to be doing a part 2 shortly after, which will go over the odd problems on the even problems on the opposite side, which will be revolved around the y-axis. So this is going to be a review of using the disk method revolving around the x-axis. And I hope to be giving you some examples, in fact 4 examples here, and then we'll have 3 examples on the opposite side. So let's go ahead and begin. Excuse my hand as I block my face. And the key here is drawing a picture. So if I'm going to draw the picture, I know it's a parabola. I can see it's clearly opening downward. It's going through the y-intercept at 4, and it's stopping at -1 and 1. So my representative rectangle is right in here. Now you'll notice this is a symmetric graph, so I can work with the even property. So I have x comma 0, and up top I have x comma -x squared plus 4. I know that if I'm doing the even property, I have 2 pi, and I'm going from 0 to 1, and I have this -x squared plus 4, the quantity squared dx. And this is what I'm going to work with. So I'm going to have 2 pi. I'm integrating after I distribute, so let's distribute first. X to the 4th minus 8x squared plus 16 dx. This is giving me 2 pi, 1/5 x to the 5th minus 8/3 x cubed plus 16x from 0 to 1. And therefore, we end up with 2 pi multiplied by 1/5 minus 8/3 plus 16, and we need to get it in terms of 15ths. So if I have the 16, we get it into 15ths, you're looking at 240 15ths. I have 24. Let's try that again. That's 40 15ths. And I have 3 15ths. So I'm looking at 243, and we're subtracting 40 of those. And we're looking at 203. Doubled gives me 406 pi 15ths. Now this might reduce. I'm not too worried about it. We can always attempt to. So 406 divided by 3, see what we get. And no, it is not going to reduce. Let's go ahead and take a look at number 4 now. For number 4, we're looking at a quadratic. Opens up, and it's going from 0 to 1. So looking at that piece, rotating around that axis, starting at 0, going to 1, and my representative rectangle, we're looking at x comma 0 and x comma x squared. So I have pi integration going from 0 to 1, x squared, the quantity squared dx, giving me pi integration 0 to 1, x to the 4th dx. When I integrate, I have pi multiplied 1/5 x to the 5th from 0 to 1, and my answer is pi over 5. This brings me to number 6. Once again, another quadratic opening up. We have y equals 0 going across like so. Now we're going from -1 to 1, using my even property, I'm just going to take half and go from 0 to 1. That point is x comma 0. This point is x comma x squared plus 3. I'm doing upper minus lower. So I have 2 pi to cut it in half. 0 to 1 of x squared plus 3, the quantity squared dx. And I then have 2 pi, 0 to 1 of x to the 4th plus 6x squared plus 3, plus 9. Let's make sure I get that correct. Plus 9 dx. We're now ready to integrate. 2 pi, 1/5, plus 2 wholes, it's cubed, plus 9x from 0 to 1. That's 1/5 plus 2 plus 9. That's 11 or 55 plus 1 makes 56. 56 doubled is 112 pi, and we are looking at fifths. And there's my answer. Number 8, square root. Square root looks like this, going from 0 to 1, so y equals 0, going up to 1. Representative rectangle, right smack dab in the middle. This is x comma root x. Down here is x comma 0. We have pi integration 0 to 1. Because we end up squaring it, it's just x dx. Pi integration gives me 1/2 of x squared from 0 to 1. And I'm looking at pi. Make sure we've got that, pi over 2. So pi over 2 is my answer for number 8. This is part 1 of the disk method. I hope that helps you. Please feel free to click like if you found it useful. And if you have comments, please make sure you give them to me so that I can improve. Thank you very much, Hornets, and we'll see you in part B in just a moment. Bye-bye.